So you know that whole idea of proportions that we were talking about? Aren't proportions part to whole, right? Well, that's what fractions are. A proportion is actually two ratios set equal to each other, and we write them as fractions. We write things as part to whole, don't we? A proportion would be two of these set equal to each other. So fractions end up being a way that we represent a lot of things, and even past just doing problems with fractions. But when you get word problems, a lot of times it's the easiest way to represent things. So we know the top of a fraction is called the numerator and the bottom's called the denominator, right? That's all stuff we remember, hopefully. Equivalent fractions are fractions that have the same value. So if you're looking on page 18 at like the problems that we assigned were up here, like 7 through 14, an equivalent fraction would be a fraction that I could reduce to a fraction that's equal to it. It's just a reduced fraction, right? So let me pick something like, I don't know, all of these don't look so bad. Maybe number 12, I guess. I can just hold this still, we'd be good. So number 12 is 24 over 28. So if you're trying to make an equivalent fraction, we could say, well, can I reduce that? What's the biggest thing that divides into 24 and 28? Does anybody know? 4 is. If you didn't pick 4, you get more equivalent fractions. Okay. So I might pick the biggest thing the first time. If I divide by 4, you know, each side, the top and the bottom, or usually don't we do this? Don't we just go 4 goes into 24 6 times, and 4 goes into 28 7 times, right? 24 over 28 and 6 over 7, they are equivalent fractions. Just to kind of talk about that idea of proportions, just to give you a little bit more math, kind of number sense, if I were to cross multiply here, I would get the same number. Since these are equal, I want you just to notice what's true about proportions. These are equal fractions. If I were to cross multiply, I'll get the same number because they are equal fractions. 7 times 24 would be an 8, carry your 2, would be what, 148? And then if I go do the other diagonal, just so you understand how proportions work, 6 times 28 would be an 8, carry your 4. 6 times 12 is, 6 times 2 is 12, and 4 makes 16. I bet I messed this up. Oh, I messed this one up on this side. Let's look at 24 times 7. 28, carry your 2. 7 times 2 is 14, 15, 16. Okay, I was trying to make a point that they're both equal, and then they didn't come out equal because I mismultiplied. But do you see why proportions work? You've got two equivalent fractions that you're setting equal to each other, and equal things will cross multiply and get equal amounts. That's why we use proportions to solve so much, is because they're just a handy way to solve. But the idea here is equivalent fractions, that 24 over 28 is equivalent or equal to 6 over 7. Okay, so you're doing some of those. 1.13 on page 18 through 20, you're doing proper and improper fractions. Once you get into this level and higher, you don't use proper fractions very much anymore. They're still having you practice here. Let's look at number 5 on this one, okay? So they give you 31 over 6, and they want you to turn it into a mixed, it says change these to improper fractions. Sounds like they're bad or something, but you know what? In algebra, this is the way we want them. We don't want them the other way. This is great. We can work with this in algebra a lot easier. But if I had a word problem and it was like, how many cups of flour do I need? 31 over 6 wouldn't tell me very much, would it? So there are times I do want to change it into, you know, mixed whole number fraction. So do you remember what you do is you say, this is the same thing as 31 divided by 6. So I could come over here and just say, well, 31 divided by 6 would look that way if I wrote it with a division symbol. 6 won't go into 3, but 6 will go into 31 5 times, because 6 times 5 is 30. I got 1 left over, so I got 1, and you remember you make a fraction and you put the thing you divided by on the bottom. Does everybody remember that, how to do that? Okay. So 31 over 6 is equal to 5. You can't read it very well, but it's 5 and 1/6. So they have you doing some of that, and really isn't this just a division problem is what it is. Division, and taking your remainder, this is your remainder here on top of your fraction, and this is what you were dividing by here. This is the 6 that you were dividing by that's on the bottom here. Okay, so 5 of the problems in 1.13 have you do that, and then I assigned 5 where you're going the other direction with it. So let's look at one of those from 11 through 15. 11 through 15, let's pick, I'm going to pick number 14, just because I can see that might, no, I meant to pick 13. I just know that 7s and 8s, people have trouble sometimes multiplying, adding, and all that sort of stuff. So they want me to change this to an improper fraction. Okay, so if you remember how to do this, don't you take the denominator and you say 8 times 4 is 32, but then I had 7 left over that I need to add in. Oh, that would have been 39 over 8 that somebody took and simplified, right?
On those,
so these adding and subtracting fractions, they're going to show up later as much harder problems, but if you understand how they work now, you're not going to have a problem with them usually later either. It's just you've got to get used to them looking a little weird. So on 1.14, we were supposed to work problems 1 through 8, so let me pick. They were kind of nice to you on a lot of these, didn't they? If you look at these problems here, a lot of them have common denominators. Why don't I pick one that doesn't have a common denominator? That way we get one of those done. We're going through number 8. Oh, every single one of them here had a common denominator in 1 through 8. I'll pick 7 just because it's got, more numbers in it or something. So 15 and 5 over 9 plus 3 and 2 over 9 plus 6 and 4 over 9. If you remember what to do here, don't you add the whole number parts up? Or you can do that if you want to. 15 plus 3 would be 18, and 18 and 6 would be 24. Now, so I got that. Let me go see what the fractions are going to look like. I know that when I add fractions, if I were to add all these up, it might help me to do this. I don't know. Maybe not. It just depends on how you like to look at stuff. It's going to be, yeah, it's going to be something over 9. 5 plus 2 is 7, plus 4 is 11 over 9. If you remember on... Yeah, because in this problem, because we got this mixture here, we're going to simplify that in a minute. Let me just remind you of the rules of addition in case you don't remember. When you're adding and subtracting fractions, don't you keep the denominator the same all the way across? And then you add or subtract across the top. So that's just the basic thing we got to remember there. Those are a little harder to do when they don't give us common denominators, but at least here they were a little nice to us. There are 9 out of 9 would be another 1, right? So let me subtract 9 over 9 from 11 ninths, and that would bump this number up to 25, wouldn't it? What would be left over? Cade said it. 2 over 9 would be left over, right? So when you get this 24 and 11 over 9, you don't want to have a mixed number that also has an improper number. That's just kind of rude, isn't it? I mean, you have to do all kinds of weird thinking there. So we would want to at least make this fraction be between 0 and 1, and we could say, well, there's a whole 9 over 9. That would be another 1 that I could take out of there, and that would make this 25 instead of 24. And there would be 11 minus 9 would be 2 over 9 left over. So that's how we're getting that. Fractions, Oh, now, okay, now I know what you're getting. Okay, so it says a cake recipe calls for 2 1/4 cups of flour. Miss Allen measured 3/4 a cup of whole wheat flour, and she plans to use bleached flour for the remainder. How much bleached flour will she need to use? How am I going to find that out? It's a subtraction problem, isn't it? Yeah. So we got a common denominator. The problem is, how are you going to take? Yeah.
And you have to borrow from the 2.
Yeah. So how do you take? What do you when you borrow from the 2? You got 1 left over. How do you write that?
4 over 4.
Yeah, 4 over 4 plus 1 over 4. Good. So 5 over 4. Now I can do it, right? Because 5 over 4 minus 3 over 4 would be 2 over 4, which I know that reduces to a half. Good. And I got 1, and there's not a whole number to subtract from the 1, so it's 1 and 1/2. So that one was a little, you just had to remember that if you can't take 3/4 from 1/4, borrow from the 1, and remember 1 is 4 over 4 in this case because our denominator was 4. Does everybody kind of remember that? Okay, let's do the other one just because usually these are the ones that people have trouble with. Plus this practices the concept. Do these at home. Oxygen makes up 3/4 of a corn plant, and hydrogen makes up 1/10 of it. How much of the corn is oxygen plus hydrogen? Was this really a subtraction problem? It's an addition problem. They stuck it in here making you think you were going to subtract. So if you think about it, you want to add these two parts up, don't you? If I want to add these up, I don't have a common denominator. Your common denominator is the same thing as your least common multiple that we talked about earlier this week. It's just we don't call it that a lot of the times. Don't we usually say, what's the smallest number that 4 and 10 will both divide into? Isn't that how we usually think about it when we look at these? Yeah, 20 would be it, right? My least common multiple here is 20. I don't have to think that word, but I'm doing it, aren't I? I'm saying what's the smallest thing both things divide into. If it's 20, that means I need to make my denominators 20. If I have a 4 here, what am I going to multiply 4 by to get 20? 5. And if I do it to the bottom, I got to do it to the top because I got to have an equivalent or equal fraction. I can't just go change the number. I just want to give it a facelift so it just looks a little differently, but it's still the same number. Chester?
I was going to say, I think I have the answer.
Okay. Well, let's work through. What I'm doing is just, you can tell me what you think in a minute. Let me work through it just in case there's anybody who doesn't remember how to do it, okay? So now, if your common denominator is 20, what am I going to multiply here? Maybe you can tell me that, Chester. What am I going to multiply 1 over 10 by?
You're going to multiply 1 over 10 by 2.
2 over 2, right?
Yes.
I'm giving it, this is just 1 in a weird form, right? And it allows me to get that 20 on the bottom so I can combine these two fractions. I'm just giving that fraction a facelift. 2 over 20 and 1 over 10 are equivalent fractions, right? They're the same thing. I just need it to look a little different so I can actually add things. This is actually an addition problem because they want to know how much of the corn plant. Yeah, you would think because they stuck it in a subtraction unit, so they're just trying to, I guess, keep you on your toes here. I bet they're looking at it as a review for those two sections or something. It's probably the people who made this up thought it. If I add these together, what am I going to get?
17 over 20.
17 over 20. 15 plus 2 is 17. And then I keep the common denominator, right? When I add and subtract, the denominator stays the same. That's why I had to get a common one. And that one really doesn't reduce because 17 is a prime number, right? So you can't divide 17 into 20. So 17 over 20 is our answer there.